So let's look at example 4. Keep going when it comes to finding if we reject or do not reject. Right, so let's suppose we have a situation here. So we have the null hypothesis is mu equals 43. Alternative hypothesis, mu is greater than 43. Pop quiz, what type of test do we have? Hopefully you guys said right tail test, right? Because it's pointing to the right, so we have a right tail test, right? We should know it automatically. Okay, they give us alpha. Now they also give us a test stat of 1.855 and a sample size of 12. Okay. Now, same thing. We want to find it. We want to find the critical value and see if we reject or do not reject. Now the problem is, right? Unlike over here where we can just go to our table, if you look at this t-values, there is no table at the bottom, right? So we actually have to do this manually. So if you guys remember how to find a t-value, it's a degrees of freedom and an alpha given to us. So that alpha is still going to be the same when it comes to it, and degrees of freedom is going to be, if you guys remember, n minus 1, right? Sample size minus 1. So that's what we have to do here. So to find the particular t-value, we have to find the degrees of freedom, which is 12 minus 1, which is 11, right, when it comes to it, and the alpha given to you. So if we go back to our portion, focus. So if we go back to our table, alpha being 0.05 and degrees of freedom 11, we get a t-value of 1.794. So that is how we find the critical values using t-values. So that is going to be the portion. And again, since it's a skewed right graph, we shade the area to the right. And again, we test it. So now our test set is 1.855. So roughly, really close to it, but still in the actual region, correct? So because it's in the region, again, wait. Oh, this is wrong. We do reject. No, that's right. We do reject the null hypothesis. Okay. Now, here's a fun fact. Let me give you a different scenario. So let's suppose I swap this. Let's suppose in this case now, the null alternative hypothesis was mu is less than 43. Okay, with the same alpha, right? We're just going to do it this way. We're going to do the same thing. We want to find the test it when it comes to it. Okay. So same thing. The degrees of freedom is still going to be 11. Alpha is still 0.05. Okay. But remember, since it's a left tail test, we're shading the left-hand side of the tail. And we're going to do the same thing. So degrees of freedom of 11, alpha 0.05, well, we get the same number, right? It hasn't changed. But here's the problem. These are all positive, and technically it should be a negative number. Well, because t-values are always just giving you on these portions, all we're going to do whenever you have a left tail test, when it comes to means for t-values, we're just going to pop a negative in front of all of these to make a negative. So what I mean by that, it's just going to pop a negative here, just like that. So that's how we're going to find critical values if we have a left tail test when it comes to t-values. So when it comes to our table, they always give you the positives, but since it's symmetric, it's going to be the negative if you just flip it on the other side. And then from there, we just test it again, right? The t-value is over here. This is 1.855. So in this situation, right, since it's not in that region, therefore we do not reject in this case. Okay? So I just give you guys a quick information, what happens when you have left tail tests based on that information there. Okay. Right. So now that we have a lot of the information down, let's try to put everything together, right? So just do a couple examples illustrating this kind of stuff, okay? Oh, my cameras are doing really annoying today. Okay, there we go. Right. Okay. All right, question 1 says, the percentage of people who like a statistics course in 2015 was 71%. So they give us percentage. That's your hint, right? A professor at a local community college believes that the percentage has increased since then. After testing his theory, he finds that the test statistic is z equals 3.12 with an alpha 0.05. Find the null alternative hypothesis. We're going to cross this out. We're not using p-values. Find the critical value and then see if we reject or do not reject the null hypothesis. Okay, so first off, right, find a null alternative hypothesis. So hopefully you guys saw what we should be doing proportion, right, because we're giving percentage, so we know null hypothesis can P equal something. Alternative hypothesis is P something, right? You know it's proportion. Okay, so we're talking about percentage the people that like stats. So this says it was 71%. So therefore, we're still thinking it's 71%, right? We're still thinking it's still 71%. According to this professor, what are we testing? We're testing its increased instance, so greater than 71%. So there, right? That's our null alternative hypothesis right there. Okay, not too bad. So okay, so that's step one, right? Got the null alternative. Now let's find the critical value. So since we're doing PPs, right, we're using z-scores. So I'm just going to have a shader. So since we have a right tail test, shade everything on the right-hand side. Okay. Alpha is given to us to be 0.05, right? Okay, so now what do we get? So going right back to our portion. So we have a right tail test. Alpha is 0.05. So our critical value is 1.645. So that's what we cook. So this is 1.645. And that is our critical value. Okay. And then finally ask us, do we reject or do not reject the null hypothesis? Well, let's see. Our test that given to us right here, so that's 3 point something, which is way over here. So remember, this goes on for infinity. So we're shading everything to the right of this value. So 3 is way out here. So technically it's yes in the region. So therefore we reject H naught. Okay. Now, here's a pop quiz. Let's suppose we wanted part B. Let's write the conclusion so you can see how you write conclusions based off this. And it's actually not that bad. Okay. So let's go back to our flow chart because that's going to be the last page and figure out how we're going to write this conclusion based off this info question, right? So always start with a start button. So does the original claim contain the condition of equality? That's a weird question, right? Let's go back over here. So here's our claim, right? It says a professor believes that a professor at a local community college believes that the percentage has increased. So does increase mean equal to? Hopefully you say no, right? It does not mean equal to. That's how you write the first sentence. So no, right, does not have equality. It says increase. So that's not a statement of equality. So that means no. So original claim does not have equality. It strictly says greater than. So that's how we do the first question when it comes to it. And the next question is, do we reject or do not reject? So in this case, we do reject. So we say yes. Yes, we rejected. And now notice we should be in box 3. So what you're going to do is literally copy what it says here. So we're going to literally copy the sample data supports the claim that, and notice where it says ... Okay, so that means we're going to go back to the original claim. And what was we're talking about? Well, he believes that the percentage claims that the percentage has increased since then. And that's how we write our conclusion. So you're literally going to copy one of those 4 boxes according to the flowchart, and then just, again, literally copy what the actual literally copy what the pre-search was actually saying, or what we want to test. That's it. That's how we write our conclusions. Okay. So let's try one more when it comes to example 2. So during a recent poll of the top anime shows, 43% of the people in the poll voted for Dragon Ball Z as a top anime. After the latest movie came out, Toei, the company that produces Dragon Ball Z, thinks that the percentage has changed since the poll came out. All right. Percentage has changed since then. After testing the theory, the company found the test had to be Z equals 1.55 when alpha 0.05. So same process, find the null alternative and all that fun stuff. Okay. So can you guys tell automatically which scenario we're in? Are we using P, mu, or sigma? hopefully you guys say P, right? Since we're given proportion, percentage, and the percentage there, right? So we know, first off, where do I find our null alternative hypothesis? Okay, so our null hypothesis, we're assuming it's still 43%, right? The alternative hypothesis is we're assuming since it has changed, it's going to be not equal to 43. Right? We don't know if it's been more or less, but it's changed since then. Okay, so that's how we get our null alternative. So now we go on to the second one. So because it has not equal to, therefore we have a two-tail test. Okay. So we know once we come to this portion, when it comes to the graph, we're going to be shading both tails. Okay. So given the alpha being 0.05 again, and since it's p's, we're using z-scores. Okay, I'll give you guys a quick second to find our two critical values. So again, it should be plus or minus 1.96, right? Good. So negative 1.96 and 1.96 positive, right? So here's 0. Okay. So now we get part of z-score test that, right? Our test that given to us is here is 1.55. So I know 1.55 is somewhere there, right? That's all I really care about. So the question is again, is our test stat, which is right here, in this region or in that region? Hopefully say no, right? It's not in the region. So therefore we do not reject H naught because it's not in the region. Okay. And then just like the top one, let's do one extra. Let's write the conclusion based off this information as well. Okay. Right, so let's see. In this case, again, we're just going to go back to the portions and see if we reject or do not reject. So let's see. So back to our flowchart. Go down. First question again. Does the original claim contain the condition of equality? Changed. So does change mean equality? No, right? Change means not equal to, right? I've changed since past tense, so it's not equal to. So again, it means no. So second question, do we reject or do not reject? So in this case, no, right? We do not reject. So we're no. So therefore, we should be in box 3. So you're either going to write, there is not sufficient